This is one of the questions.
Go look here. Write a fourth degree polynomial with integer coefficients that has zeros at x equals 1, multiplicity 3, and x equals -3. Are you allowed to use your calculator on this?
Yeah.
Okay, so one way to do this problem, which I don't know, depends how fast you're with your calculator, is you could graph the first one and decide if it has this behavior. Then you'd have to graph the second one and so on and so on. That's option number one, is to use your calculator. Second option is to actually write the factored form, but then you have to expand it. Now, you could do kind of a little bit of both. So the last term is the product of these, which means you're down to t and u.
Got it.
That's like a test taking strategy. If this is for your response, you're gonna have to
I
work it
think I
out. So
started with the part where it's multiplicity of 3 because I tried to do it, but I kept on getting x to the 5th as the first um instead of x to the 4th, and that I don't know how I got x to the 5th, but so I got for the first part of it y equals x to the 5th and another. So I think that's how I was
okay.
confused.
Alright. So you've got a choice now. Either graph, the first one or the second one, see which one does it, um, or actually expand this. And this is the Pascal's triangle thing, or it's x minus 1 times x minus 1 times x minus
This
1.
one. So if you were equals you. All right, I got it by graphing and BT.
First one?
Yeah.
All right. All right. There's also another little thing that this x minus 1 cubed alternates signs. So the final answer would also alternate in signs. But anyway, that's all side stuff. So
All right. I'd like some practice with problems like 8 and this one that I'm gonna put in the chat, which is number 7.
Want me to make some up like this, or do you want to try this
Yeah,
one?
we can make it just make me we can do this one like it.
You want like this?
Yeah.
Okay. Yeah, I mean it's the key thing here is the uh this 4i business. So um let's just say I tell you in a new problem here that x equals 3i is a root. You're supposed to also know that minus 3i,
Yeah.
and then you have to be very fast at then multiplying these together. If you can, you want to be able to do it without even foiling. Any idea what this becomes without
X
foiling?
squared plus 9.
Yeah. So then you pair that up with, okay, there's another root or 0. Let's just do x equals -2, multiplicity of 2. So that is x plus 2 squared. Is it clear where that comes from?
Yeah.
So that becomes x squared plus 4x plus 4 times x squared plus 9. And you have to be able to multiply this out. So this is where I'd like you to kind of jump in and multiply that out for us, please.
All right, I got x to the fourth plus 4x cubed plus 13x squared plus 36x plus 36.
Okay, very good. So that is correct. That was very fast also. So when you look back at this problem, let's see if we can whittle it down to 2 answers quickly. So the 4i and the minus 4i becomes x squared plus 16. And then you have x plus 3 squared. So the 3 squared becomes a 9 times the 16 becomes 144, which gets you down to those two. You've got to find some places to save some time on the tests. And this would be one of them.
Got it.
Now there's also this thing you might have noticed at some point. If you have like x plus 1 squared, it becomes x squared plus 2x plus 1. Notice it has 3 terms. X plus 1 cubed. I don't know what it is, but it ends up having 4 terms. So you always tend to get one more term than the expansion of this. So you can also kind of use that here on this, like a 4th degree polynomial probably is going to have 5 terms. Does that always work? No, but that could
In
also
this
help.
case, wouldn't it be E?
Yeah, there was Q. Yeah, teachers using weird
Oh
using
yeah,
it.
Q.
Okay. You want me to give you another one like this? or something else?
Um, Probably another one like this would be,
Well, so the one we haven't done, and I do feel like we oughta, I mean, at least touch
yeah,
on it, is like, let's say I tell you the root is square root of 3. What's the other root that goes with it?
square root of 3, uh,
Negative square root of 3.
yeah, negative 3, square root of 3.
So that becomes x minus root 3, x plus root 3. Could you FOIL that for us as well? Then we'll do one a little bit more difficult.
I got x plus 3.
X squared plus 3.
X squared, yeah, x squared plus 3.
Sorry, it should be a minus 3 though. Sorry, minus 3. Because the last minus root 3 times root 3.
Uh,
Is that okay?
yeah,
Now let's pair it up with, we'll make this a little bit weird, I square root 2. What does that go with?
that would go with x minus I square root 2 and x plus I square root 2.
Yeah, it goes in minus I squared 2. So yeah, let's have you try to FOIL that, reduce that.
Okay, I got x squared plus 2I.
I's have to go away. It should be x squared minus I squared times 2. Because the O and the I cancel. That's the whole point of these problems is they're, so this becomes x squared plus 2.
Got it.
I squared is negative. Now I want you to FOIL this last one. You'll see it's an exception to what we did earlier. You have an answer for me for this?
I got a little bit stuck.
We're just foiling here. X to the fourth minus 3x squared plus
Oh,
2x squared minus 6.
oh yeah. Yeah, it's finding the wrong thing. Okay, yeah, that makes more sense.
So final answer here is x to the fourth minus x squared minus
Minus
6.
6.
So notice this violates kind of what we just previously talked about, the number of terms, so you can't always use that. But
Got
something to
it.
think about. Okay, happy to give you another one like this, or if you got some other stuff you want us to work on,
See.
I can make up some problems as well.
Let me pull this one. Okay, let me put this into the chat. So this is the review for next week's test. Kind of continuation for the review that we do right now. This is over the whole calculator OK portion. So from 4.10, so from the last few lessons. Let me find there it is. Okay. Let me put it into the chat. All right, I think you should do some problems from the review packet you posted on Google Classroom for the chapter 4 test we have next week.
Yeah, so is there some on here you want us to look at? All of them, some like, I mean, we've looked at problems like all of these, over our lessons, but where do you want us to start?
Why don't we start, actually, not there. Why don't we start at number 4? I think, yeah, I think we've done the
Okay,
other one. Actually, no, maybe number 3, actually. Number 3 on the first page.
okay. Yeah, we looked at these the other day. You almost want to like answer the other way to answer these questions was a little bit different than what we did the other day, is to figure out like where is this true? Where is this true? And then look for the overlap between them. So like where is f of x greater than or equal to 0? That's from minus infinity to minus 3. And then you can see again it crosses at 0, 0 comma infinity. What I was trying to do is get you to sort of pick one, and that's kind of your like limiting. You then look in those intervals and decide, well, is the other one ever true? So the other way to do it is to figure out the overlap. So the next one there, I think is a little harder to do, but g of x is greater than 0 from minus 2 to infinity. So then you have to decide, well, where do they overlap? Where are they both true? I think that's, so the one way to do it is draw a number line and label like, okay, that's -3, that's 0. And then do the other one. And so it's like a shading exercise. It's like, okay, this is true here and here. And then for the other one, it's true over here. Where are they both the same? Where's the overlap?
I think that's what we did in class. Like we do the number line thing and the open circle and closed circle to see
Yeah.
which is the overlap.
You'll do this again in calculus. So it's a good strategy. But the answer here is just sorry, that's a bracket there. It's bracket 0 to infinity. Which these should be brackets as well. Let me know if that's clear or if you need any.
Yeah, I get it.
All right, for part B, u of x decreasing. That means it's going down and to the right. So g of x is this red graph. It's only going down and to the right from -1 to 1. And then f of x greater than 0. We kind of already answered that, but it's not included this time. So it would exclude the that, and then from 0 to infinity. So you could do the same thing. You can make two number lines. There's -1 and 1. There's 0. There's -3. So you can sort of, okay, open circle in between, open circle, and then figure out the overlap, which is from 0 to 1, open interval.
Got it. Yeah, yeah, I get it.
So I could certainly come up with some problems like this if you would like, or we can just keep going down the review.
I think we'll just keep going down the review to see what types of questions there are.
So 4, go to 4 then. So why don't you try to answer as much of this as you can?
Yeah, the zeros are at negative or 0, negative.
You read
Here's
left
this.
to right.
Yeah,
Just
so
like
the
this.
zeros are from -7, 0, 4, and 6. And then the maximums are 3, 3, 7, and then
Nope, try again. 3, 3, 7 is like, I don't know, up here.
-3. -3, 6.
Yeah, so -3, comma 6.
And then negative, wait, yeah, no, not negative, 4, or 5, comma 4, yeah.
Okay,
And then minimums would be 2, comma -2.
okay. All right.
Intervals where f of x
So
is
just a reminder
increasing.
on increasing, decreasing, and even the next ones, these are all the x's. You don't care about the
Got it.
y's, just
So it's increasing from -infinity to -3.
good,
It's decreasing from -3 to 2.
okay,
And oh, it's another interval that it's increasing is from 2 to 5.
good.
Another interval it's decreasing is from 5 to negative or to infinity.
So if you're ever really stuck on that, you could make a number line where you have these maxims. Is actually what you do in calculus, increasing, decreasing, increasing, decreasing. And that'll give you your number line. And then you can do the same thing for, less than 0. Be very careful there. Less than means it's going to be parentheses.
Okay, and then intervals for which f of x is greater than 0 would be
Less than 0. This one's less than
less than 0 would be -infinity to -6.
7. It's your zeros. You gotta have you're gonna use your
Oh
zeros.
yeah. Right.
And then it does not include -7. Very important.
So then it's not including 0 to 4,
Good,
and then not including 6 to infinity. Yeah.
good.
And then intervals for which f of x is greater than or equal to 0. So that's from 7 including 7 to 0 including 0. And then from 0 including 0 to
Yep,
4 including,
up
actually no,
below.
that's below.
Yeah.
That would be from 4 including 4 to 6 including 6. Yeah.
All right. Now that possible formula for f of x really comes from the zeros. So that's the answer in factored form. If it didn't specify, I would leave that. There's also a value of a to consider. I don't know how, teacher probably will want that. So to find that value of a, you would use like one of these other points to find it.
Got it.
So kind of like, and you can use factored form to find it. You could do 6 equals a -3 plus 7, -3 minus 4, and you know, go from there. We don't have enough time to do problem 5, but like question, I guess, this is one of the things I would want to ask in the classroom is like, will I be allowed to use a calculator
Yeah, I think
or
on,
by
yeah, so this
hand?
test will be allowed to calculator.
Okay, because that does impact how you do it. Okay. All right, any other questions or thoughts before we close out today?
Not really.
All right, I'll get back to you on some times here.